This actually explains it all. If excess load is placed on the muscle, the Golgi tendon reflex becomes activated, causing the muscles to relax. Relaxation of that muscle would ultimately protect it from damage. Alright? Okay, we shall now look at the withdrawal reflex. Okay? The withdrawal reflex is a reflex response to nauseous stimulus, which are applied to the skin or subcutaneous tissues or muscles. Alright? Nauseous stimulus are very painful or harmful stimulus. Functionally, the withdrawal reflex helps us to withdraw our bodies from injurious or potentially harmful sources. Okay? That is the significance or the importance of withdrawal reflex. Okay? Fantastic. Now, for instance, stepping on a hot object with the bare foot. Have you ever stepped on a hot coal? Oh my gosh. Nobody will tell you to withdraw your legs. Alright? Good. That is withdrawal reflex. Alright? Names have meaning. Withdraw. You withdraw the body from potentially harmful objects. Going forward, there are two components of the withdrawal reflex. The first one is known as the flexor reflex, while the second one is known as the cross extension reflex. These are the two major components of the withdrawal reflex. Now, flexor reflexes are usually ipsilateral. That is, they occur on the affected limb. Okay? Now, during flexor reflex, there is reflex contraction of the flexor muscles and simultaneous relaxation of the extensor muscle. Okay? Fantastic. Now, functionally, the flexor reflex or flexor reflexes helps us to pull or withdraw the limbs from potentially harmful stimulus. Alright? Going forward, the extensor reflexes are usually contralateral. That is, they occur on the opposite limb. Alright? During cross extensor reflex, there is reflex contraction of the extensor muscle and the simultaneous relaxation of the flexor muscle. So the cross extensor reflex is the opposite of the flexor reflex. Alright? Going forward, functionally, the cross extensor reflex helps us to maintain balance or to stand upright while the other leg is withdrawn or lifted or flexed from the potentially harmful stimulus. The flexor reflex helps us to withdraw the limb from potentially harmful stimulus. Cross extensor reflex helps us to stand upright or maintain equilibrium while the other leg or the limb has been withdrawn from the harmful stimulus. Alright? Okay, now this diagram explains the flexor and extensor reflex, which are together or collectively known as the withdrawal reflex. As you can see, this person steps on a very hot object. Now, immediately that happens, the legs are flexed or pulled away from the harmful object. This is known as flexor reflex. The opposite leg of this person is extended, and this helps him to maintain equilibrium when this leg is lifted up and withdrawn from the harmful stimulus. Now, without the cross extensor reflex, this person will not be able to maintain balance or equilibrium when this leg is lifted up. This would lead to this person falling to the ground because equilibrium is lost. Alright? Now, without the flexor reflex, this person will not be able to withdraw this limb from harm. Alright? So the flexor reflex are very, very important in helping us to withdraw our bodies from potentially nauseous stimulus, while the extensor reflex helps us to maintain equilibrium or balance when the flexor reflex is active. Alright? Fantastic. Okay, we shall now look at the withdrawal reflex of the quadriceps femoris muscles and the hamstring muscles. The stimulus here is stepping on a hot object or a sharp object or any potentially harmful object. The sense organ here is the nociceptor. Remember, for stretch reflex, The sense organ is the muscle spindle, while for the inverse stretch reflex, the sense organ is what? The GTO, alright? Okay, the afferent component of the withdrawal reflex is the A delta neuron. The center is the CNS, that is constitutes of the brain and the spinal cord. The efferents are the alpha motor neurons. The effectors are the quadriceps and hamstring muscles. Of course, we are looking at the withdrawal reflex of the quadriceps and hamstring muscles. The response are 1. Contraction of the hamstring muscle and relaxation of the extensor muscles. B or 2 is relaxation of hamstring muscles and contraction of quadriceps femoris muscles. Going forward, this diagram explains the neurocircuitry of the withdrawal reflex of the hamstring and the quadriceps femoris muscles. Alright, supposing this is Ransom. You know Ransom in physiology? Yes, this is Ransom going to visit his girlfriend, his baby. Now on his way, unfortunately, he stepped on a very sharp nail. Of course, that has ended the journey to his girlfriend's house. Now, his stepping on the sharp nail is the stimulus for this reflex. This stimulus stimulates the receptor, which is the nociceptor. The nociceptor, upon activation, stimulates the afferent neuron, which is also known as the sensory neuron. The afferent neuron carries the information from Ransom's leg to Ransom's spinal cord. Diagram B shows the enlarged events taking place in Ransom's body. Now, in the spinal cord, the afferent neuron splits into 4 parts. Alright, this is the first part, this is the second part, this is the third part, and this is the fourth part. The first part, synapse with interneurons. Alright, the interneurons secretes inhibitory neurotransmitter. This inhibitory neurotransmitter is carried by the motor neuron or the efferent to the quadriceps femoris muscle. Alright, remember the muscles at the front of your thigh is the quadriceps femoris muscle. When this inhibitory motor commands gets here, it causes these quadriceps femoris muscles to relax. Okay, the second part of the afferent neuron does not synapse with interneuron. It immediately synapses with the efferent neuron. This efferent neuron now carries excitatory motor commands to the hamstring muscles, which is located at the back of the thighs, causing it to contract. Now, relaxation of the quadriceps femoris muscle and the contraction of the hamstring muscle would now cause Ransom to lift his leg or withdraw his leg from the sharp nail. Alright, this is known as Flexor Reflex. Now, the third part of the afferent neuron synapses directly with the efferent neuron. This efferent neuron sends excitatory motor commands to the quadriceps femoris muscle, causing it to contract. Alright, the fourth part of the afferent neuron synapse with interneuron, which secretes inhibitory neurotransmitter to the efferent neuron. The efferent neuron now sends inhibitory motor commands to the hamstring muscles, causing it to relax. Alright, now in Ransom's first leg, there is relaxation of the quadriceps femoris muscle and contraction of the hamstring muscles, which ultimately leads to withdrawal of this leg from the sharp nail. Alright, in Ransom's opposite limb, there is contraction of the quadriceps femoris muscle and relaxation of the hamstring muscles. So many things are happening here, and this contraction of the quadriceps femoris muscle and relaxation of hamstring muscle helps Ransom to maintain equilibrium or balance while this limb has been lifted up. This phenomenon is known as the withdrawal reflex of the quadriceps and hamstring muscle. Alright, going forward. Now, We shall now look at the withdrawal reflex of the biceps muscle. Now, this diagram represents the withdrawal reflex of the biceps muscle. This is Chidinma Paulinus. Alright, she was going to the kitchen to steal meat from her mommy's pot of soup, but unfortunately her hands got burnt by fire. Alright, so those of you who know how to thief meat from your mommy's pot of soup, like Chidinma Paulinus, one day fire will fire your hand. Alright, good. Now, when this happens, efferent information was sent to the spinal cord, alright, via the afferent neuron. The spinal cord processes the information and sends down motor commands back to Chidinma's biceps muscle. The first motor command, or afferent, goes to the bicep muscle, which causes the bicep muscle to contract. Alright? The second afferent goes straight to her triceps muscle, causing her triceps muscle to relax. The contraction of the biceps muscle and relaxation of the triceps muscle will now cause Chidinma to withdraw her hands from the hot fire or pot. This is known as withdrawal reflex of the biceps muscle. Alright, so basically the withdrawal reflexes helps us to withdraw our bodies or body parts from potentially harmful stimulus. Alright, fantastic. Going forward, alright, we have come to the end of today's lecture. Our quiz for today is a very simple one. Outline 10 importance. I said 10, only 10 importance of body reflexes. You see, I'm very nice. I didn't say you should write 100. 10. Alright. Up next is pain physiology. Alright. You are all going to become professional medical doctors, medics. Pain physiology is not a course that you should miss. I'll be exposing to you some things you need to understand about your profession, why you are a doctor and what you should be doing as a doctor. Do not miss out on this, otherwise you will cry. You will so regret. Alright, thank you for staying tuned. I remain your anchor and facilitator for this course is neurophysiology, and let's do it again next week. Bye.